Hello friends, this is Shravan Kumar Manthri. Welcome to our channel CSE GURUS. As part of the technical C, so in this video we'll see the concept of sorting. The techniques as well as the complexities. Of course the complexities are very most important, right? So we'll see all these things in this series of video lectures. Before that, I'm very much happy for the response of the videos like top 100 CMCQs and next 50 CMCQs. So thank you for your great response for these two videos. Moving on to the concept of sorting. Okay, so we'll see what is this sorting first of all and the sorting techniques with their complexities. So what is sorting? Of course it is a process through which the data are arranged according to their values in, it might be increasing or decreasing order. If you see like this, let us suppose these are the elements you have, these are the elements in a list. So 34, 70, 91, 86, 15, 43. So how this list can be in an arranging? It might be increasing. Of course, you can make it in decreasing order also. Right? So here we can see this is increasing order. How to make it? What are the methods we have? What are the techniques we have to make it in a proper manner? That is in an arrangement. Okay. So that's what it might be, increasing or decreasing. How to do this one? So that is what we have to see and we have to analyze. So in this series of video lectures I want to cover these sort of the sorting techniques. You can see selection, bubble, insertion, quick merge, heap sort, radix sort, bucket sort, counting sort, as well as of course the sorting the strings in a dictionary order. That means a set of names are given, so how to sort according to the dictionary order. Okay, so like if a name starts with A, if both the names are starts with A, you have to check with AA. Is that right? So how to do all these things, that also we'll see. So these are the sorting techniques. Not only this, if possible I'll cover more sort of the sorting techniques like topological sort is also there and much more, and sorting the elements in a matrix, how to do. Of course all those things I want to do, I want to cover. And of course the very much important, I told you, like complexities. So what are the complexities? So we'll see, we will compare one sorting technique with the other one and which is the best one and what sort of the technique. Some sort of the techniques where the swapping is a major part and some more where which are non-swapping sorting techniques. So what are those, how to do? So all those things we will see in the series of video lectures. Yeah, moving on to the first one, selection sort. So what is the selection sort? Of course any sorting technique, if you observe, you can find the meaning of the sorting in the name itself mostly. Okay, so in the selection sorting here also, so the selecting an element, selecting a value which is either minimum or maximum. If it is increasing order it might be minimum, if it is decreasing order it might be maximum. So you have to select and keep it in a particular place, that is might be in the beginning. Okay, so let me take an animated way where the list of elements to be sorted using selection sort. Of course I mentioned here the selection sort uses sorted sublist and unsorted sublist. Your list, your array will be divided into two parts. One is sorted sublist and another one is unsorted sublist. Of course in this one we'll see selection sort with example. Of course what is a program? Of course C program without separate function, with separate function. Okay, we have to define a function, right? So how to get a program with separate function, or we can write in main function directly. Okay, that is not a big deal. And execution, of course I execute both. Okay, I'll show you. Sorting only first half of elements, you want to sort only half of the elements, how to do? Sorting only second half of elements, what sort of the minor changes I need to do? Okay, so that is all. And some questions will be asked like arranging the only first half of elements in increasing and second half of elements in decreasing order, how to do? And finally analysis, that is a complexity of a selection sort. Okay, so these are the things we'll see now. So the example you can see here, so I have taken the list. Okay, initially of course here I have given the list sorted sublist. That means the line where I have provided this black line, this separator, which the left part will be always sorted and right part will be unsorted. Initially all are unsorted, right? Initially the elements are unsorted. Of course, might be you can give the sorted list also. That is not a wrong one, of course. But whenever I say this line, the left elements will be sorted, right elements will be unsorted. Initially the process not yet started, that's why left of the line is empty. That's why sorted list is empty, unsorted list is full, you can see. Now the first step, what is that step? I told you, like, the first thing you have to find, let us suppose it is increasing order, you have to find the minimum among all the elements. Initially all the elements, of course I can say it is like minimum of unsorted sublist. You have to find minimum of unsorted sublist. So what is the minimum of unsorted sublist? So you can see here among these elements 8 is the minimum, right? You have to get that element, smallest of all the elements logic you can use, and you will get that 8 is the minimum. Now what you need to do, whenever you get a minimum element, what you need to do, you have to swap with the first element, initial element, okay, in the unsorted sublist. Remember this point, you have to sort with minimum element, you have to swap with minimum element and the first element in the unsorted sublist. You can see first element is 25 and this minimum element is 8. Now I'll swap, you can see, yeah. Now the separator, you can see left part is sorted, right part is unsorted sublist. Now what is the minimum value? 25, right? So 25 to be swapping with, I told you, the first value in the unsorted. You cannot swap with 8, right? It is a sorted one. So 85 and 25, is that right? So minimum value is 25 among unsorted sublist and my first value is 85. So swap. Now it will become like this. Now the separator will be here. Why? Because 8 and 25, two elements are sorted, the remaining elements are unsorted. Now again from the remaining elements you can see, of course, the 32 is minimum, 48 which is the first element in the unsorted, swap it. Now the separator will be here. Now 85, 48, 56, which is the smallest? 48, yes, fine. So swap with the first element 85, okay, yeah. Now the separator will be here. You can see 4 sorted elements, only 2 unsorted. Again you continue, of course 85 and 56 sorted like this. Now the things to be observed here is, the first thing, you have to find a minimum element. Of course if you want to make it for decreasing order, you have to find maximum. Second thing, swapping. Am I correct? The third part, which is, you can observe one more thing, like if there are n elements, let us suppose how many elements are there? 6 elements are there, then you have only 5 pass. That means if there are n elements, you have require n minus 1 passes. That means for the last element, of course not required to pass, right? If there are 20 elements, 19, at most 19 passes are enough. Is that right? So these things you need to consider, and like this it will be. So in the selection chart, you have to select the value which is the minimum, then you have to swap with the unsorted sublist. Like this it will be, finally all elements will be sorted. Of course if you want to make in decreasing order, you have to select the maximum element, okay. So keep it in the swap with the first element in the unsorted. Now you will get the decreasing order. That's it, right? So this is what the procedure you can find for selection sort. So this is an example. Of course if you want to try, you can try for this. You can take this element and you can practice. You can take these elements. What is the minimum element? 15. So you have to swap 15 with the 34, right? So here 15, here 34 will come, and what is the next smallest among these elements? 34. So 34 will be swapping with 70, like this. So this is what the procedure you need to follow, and next smallest among unsorted sublist will be 43, right? So like this. So this is what you can complete this procedure so that you will get the elements. So now this sort of the selection sort procedure, how you can implement. So I told you the first thing, you have to find the minimum. Second thing, swapping with the unsorted, so the first element of the unsorted. So how to get that, I'll directly show the code and afterwards I'll execute also. Okay, yeah, this is the code. You can see the selection sort process. So initially I have taken an array, of course the size you can take any. Okay, I've taken very less size. Okay, yeah, minimum, a variable to get the minimum index. Okay, yeah, temporary variable to swap. Okay, I've taken, anyway we can see, enter the size of an array. So I'll enter the size, how many elements you want to take and what are those elements I have given. Because this part is just to declare, I mean to get the, to take the inputs. Okay, this part is a declaration, this is taking the inputs till the line 10, right? Now the logic resides from line number 11 up till 22. Okay, yeah, you can see here for I equals 0, I told you yn minus 1. So that's what this process, if there are n passes, n variable, if there are n elements, you require n minus 1 passes only. So that's why you can see here 0 to up to n minus 2, right? Yeah, that is what, that means less than means. So that is what here we require. That's why it is n minus 1 times I need to do. What I need to do, I have to find the minimum in the unsorted sublist. You can see here minimum equals to initially starting with 0. So initial value is 0, minimum. Now j starts from what? I 0 plus 1, 1. So you are finding, this is a logic to find the minimum, the index of the minimum value. Of course, if you see here, if you apply here, if you trace minimum equals 0, j equals to 1. If a of j, what is a of 1? This is index starts from 0, right? So like this indices. So what is a of 1? 85. Is that 85 is less than, minimum is 0. 85 is less than 25? No, right? Next j value 1, next j value 2. 48 is less than 25? No. Next j value 3. 8 is less than 25? Now it is true. Now minimum is changing. Minimum is changing from 0 to 3, right? Yeah. Now j value will be incremented to 4. Now 32 is less than, shall I check with 8 or 25? 8 only. Why? Because minimum, the index is changed. So 32 is less than 8? No. Is that right? So now it's not changing. Next one, j value is 5 finally. And 56 is less than 8? No. So then j loop completes and now completed. So what is the minimum index? 3. That means what is a of 3? 8 is the smallest element. Now I need to swap, right? 8 with 25. You can see I have taken temporary. Temp equals to a of I. A of I means what is I value? 0. That is a of 0, 25. Next a of I equals to, so what is a of 0? Equals to a of min, a of 3. It is 8. And a of min is nothing but a of 3, which is equals to temp, which is therein, that is 25. So a of 0, 8. A of 3, 25. So simple swapping, right? So this part has to be completed like this. Finally you may print. This process has to be completed. Now minimum equals to I, that means min starts from 1, right? So that means only this is a sorted, this is unsorted, and this part has to be completed up till, that is it started from 0, that's why n minus 2, right? So this is what the program of selection sort. Of course this logic I implemented with separate function, that also you can see here. So here selection set, of course I have, instead of writing the logic directly, I apply, I'm calling selection of a is an array, comma n. Of course simply a, if you call this, directly goes to the address of a of 0, right? So concept of the pointer, and here it goes, and again the logic is same. Instead of taking min, I have taken small here, the variable, and again the same thing will be printed, right? So now we'll see the execution part. Okay, we'll see the outputs first. Okay, how it can be executed. I just copied this program, so that is a main function. I have taken the element selection function, and here it is a selection function. This is a logic for finding the smallest. Here this part is finding the smallest, and then whatever the answer you are getting, so from that swapping. Okay, yeah. Then we'll see the execution part of this one. Yeah, enter the number of elements. Here we can see, let us suppose I'll take the elements like 6 elements. The elements are something like 25, something like 56, I'll take something like 8, 85 I'll take, 72 I'll take, so one more element 65 I'll take. So the output we'll see. Yeah, you can see the elements which are 25, 56, 8, 85, 72 and 65. You can see the output 8, 25, 56, 65, 72, 85. So which is a sorted one. Now you may think that, okay, if you want to see the entire process, how in each pass it has to select the smallest, right? So that we'll see now. Okay, what are the changes you have to do? So what I'll do here is, this for loop, instead of writing outside of this for loop, anyway this is outside the I for loop, right? So I'll keep this one inside. That means every time what happened, like how the elements are printing. Okay, instead of taking I variable, why? Because I value is changing every time, right? So I'll make it as k. So this is simply to show effective. That's it. So k, of course the k variable has to be declared. Now the thing is, every time it has to print in new line, right? So I'll keep here as printf 1/n I'll provide, so that will be printed in new line. Now we'll see the output. Yeah, elements I'm entering something like 25, 86, 8. So enter the number of elements. I'll take something like 7. So the element is like 25, 86, 8, 35, something like 56 and 72. Okay, one more element has to be given, right? 7 elements, something like 43. We will see this output. Yeah, in the first pass you can see 8 is the smallest, 8 is kept. The remaining elements you can see 86, 25 are unsorted. In the next pass, in the second line, 8, 25, 86, 35, 56, 72, what is the smallest? 25, of course kept here. Now from the next one you can see what is the smallest? 35, you can see here. Next 4 elements, what is the smallest? 43 here. Next 3 elements, 56, 72, 86, 56 is smallest, and 72, 86, 72 is smallest. Now one more thing also you can observe here, 7 elements, how many passes are completed? 1, 2, 3, 4, 5, 6. That's what, n elements are there, n minus 1 passes are required. So like this we can get the output. See, the questions which we have completed here is selection sort example is over with the without separate function. With separate function, of course, both execution, of course I have shown you. Only now we have to see what is only first half of elements to be sorted, what is only second half of elements to be sorted. Okay, we'll see this one also. Very simple thing which we have to do. Okay, so we'll see that one. Let us suppose these elements are given. I want to sort only half of the elements, 25, 85, 48. What will be the output? 25, 48, 85. This part should be as it is, right? If I want to only sort second half of elements, 8, 32, 56, what I need to do? Where the logic has to be changed in the R program. Okay, where I need to change, we'll see now. Yeah, in my program you can see here I've taken the entire elements, but I want to sort only half of the elements. That means we have to go for, if there are n elements, we have to sort only n by 2, right? So where I need to change, I need to go for only first half of element. That's why first I want to make only n by 2, that is I less than n by 2, right? N minus 1 by 2 is there, so only half of elements. Okay, we'll make it some changes so that we'll get the output n by 2 minus 1. Is there any need to give braces like this? I think not required. Why? Because division is the first priority. Why I have given minus 1 means, let us suppose if there are 8 elements, the index starts from 0, right? 0 to 7, right? So we need to sort up to index 3. Why? Because 0, 1, 2, 3, right? So that means we need, in order to get 3, we have to write 7 by 2, which is 3 minus 1, up to 2 only it is taking, right? So I think n by 2 is fine. Let us suppose if I take n by 2, 8 by 2, sorry, 8 by 2, which is 4. Okay, so that's why minus 1, right? If there are 7 elements, 7 by 2, which is, of course, yeah, half. If it is odd, only you have to take, you need to check it out which part you require. According to that you can change this one, right? Yeah, here also j less than y to that n by 2 is fine, right? So only half of the elements. I think that's it. We need to change in this function, that is selection function. Nothing more to change, right? So anyway, we'll see the execution part of this one. Yeah, enter the elements. I'll take the elements, 6 elements, something like 45, 76, 24, then 7 I'll take, and 85 I'll take, 32 I'll take. So the output should be only first half of elements, that is 45, 76, 24, which becomes like 24, 45, 76, and 7, 85, 32 will be as it is. We'll see the output. Yeah, you can see the output. Anyway, I've written the for loop inside, right? That's why. So 25, 40, 24, 45, 76, which are sorted, and second half 7, 85, 32, which are unsorted. So only one time the last part you want to print, you can take it. You can keep this one outside. That means simply this closing brace you have to keep here. That's it. So you have to keep that. So you have to keep that brace outside. So this is what one change. If I keep this brace here inside, that means there is a loop inside and every pass will be printed. If you keep this for loop outside, only final answer will be printed. Now we'll see this output. I'm taking 6 elements, 43, 25, 78, 9, 65, 27. Okay. Yeah, now you can see the answer. Only first half of elements 25, 43, 78 are sorted. The remaining half elements 9, 65, 27 are unsorted. That is, you don't want to change. Okay, so like this we can go for only first half of elements to be sorted. What if only second half of elements to be sorted? Let us suppose if I give the same elements 43, 25, 78 to be same, unchanged, and only 9, 65, 27 which is to be sorted, 9, 27, 65 to become. So what we need to do in our program? So what are the changes I need to do? Anyway, I'll keep it my original complete sort program. In that only we have to see, so that you can understand it easily. Yeah, now in this I want to sort only second half of elements. I think we have to do only one change. What is that? Here you can see I starts with 0, right? So instead of I starts 0, I'll start I with n by 2. That's it. No need to change I less than, no need to change j less than. That's it. I think if you want, you can check it out. Anyway, some minute changes according to your output, like if it is odd size, you can make it. Okay, so my intention is to tell, like, so the remaining part of the program is unchanged, right? So if I take the elements 25, 45, 32, then taking 9, then 65, 54. So you can see the output now 25, 45, 32 as it is, and 9, 65, 54. If I sort, it will become 9, 54, 65. So like this we have to do. So that is for second. Okay, yeah. Now the thing is, we have completed like first half of element only to be sorted, second half of elements only to be sorted. Now the next question is, you have to sort first half of the elements in increasing, second half of elements in decreasing, right? So of course you may have some methods, but what is the best, what is the easiest one? Like when you code, how you can get the answer when you are already with this answer? What you need to do here, that means I want to sort only first half of elements. So first that is increasing order, second half in decreasing order. Okay, and one more thing you can see here, all the elements, let us suppose if I keep the original one, this one, this is the program where it will print all the elements in increasing order, right? So what if I want to make it in decreasing order? That means what is the only one change you have to do in this one? That is, instead of a of small greater, you have to keep it as less than. Of course your total elements will be in decreasing order. Of course you can see this one also, the output. Let us suppose if I give 6 elements, 25, 8, 89, 43, 5, 54. So 6 elements, you can see the answer: 89, 54, 43, 25, 8 and 5, which are decreasing order. So now the question is asking to make first half of an increasing, second half in decreasing. So the very simple answer what I'll do here is, this logic is for increasing order of the elements. Now what I'll do here is, I'll just copy it. First I'll copy this part, so in the next line immediately I'll paste it. Okay, now the first part I will take, and this I'll use for first half of elements. This part, which is a copied one, I'll use for second half of elements. Now you can see here how to get the increasing order of first half of elements. Anyway, we have done it. We made it n by 2 minus 1, and this one also n by 2. So this is for increasing order of the first half of it. And what about this one? Here I have to use for second half of elements. Anyway, first thing it should be decreasing, right? So first thing, greater than should become less than, right? And for second half of elements, I told you like only to change, I starts from n by 2. That's it. Okay, so like this, and the remaining things to be unchanged. So this for loop is from 17th line to 29. It is for increasing order of first elements, and the 30th line to 42, this is for decreasing order of second half of elements. We'll see the output. Enter the number of elements. 8 I'll take. Okay, 34 I'll give 76, 8, and then 89 I'll take. Second half of elements I'll take 70, 74, 43, 7 I'll take, and then 65. So totally 8 elements. We'll see the output. See, first half of elements 34, 76, 8, 89, these are in increasing order. Second half of elements 74, 43, 7, 65, these are in decreasing order. So like this we have to make increasing and decreasing orders. So only first half of elements in increasing, second half of elements in decreasing order. So we have to change the code. So here my intention is to explain, like if you know the answer of this one, how to sort the entire elements, you can make some changes so that you can get how to take sort, only first half, only second half, arranging in first half in increasing and second half in decreasing. This might be very easy. Okay, so this is what, and the final one, complexity. So what is a complexity here? Coming to the complexity part, even if you see in selection sort, where even if you give any order of elements, any type of order of the elements, even if you give increasing and decreasing, this process has to be completed, right? Like every time I starts from 0 till goes to n minus 1, j starts from I plus 1. Okay, yeah, so that's why the process which takes the nested for loop must be completed. So that's why it will be taken as n square. So the complexity will be order of n square, even in best case, worst case and average case also. So there is no special constraint like how to make in like which should be less than the n square. So this is what about selection sort program. So now we'll go for the concept of bubble sort, and we'll see all these things. Bubble sort. So it is again the list is divided into two sublists, sorted and unsorted, but of course same like in selection sort. But what is the difference here? That we have to know. In each pass, the smallest element is bubbled from the unsorted sublist through adjacent swapping. So I kept it as bold, that is adjacent swapping. This is the main part that we can see in bubble sort, where it might not be in selection sort, and move to the sorted sublist. Anyway, we'll see this animated way. So how this can be happened in adjacent swapping. So that is what, like if you want to make it a sorted order, let us suppose if you want to make increasing order, so whichever the largest element will be kept at the last, and next largest will be at the last but one, like this. Or you can consider like whatever is the smallest, you can keep it in the first position, second smallest in the second position, third smallest in the third position, like this. So this is another one. And in each pass, the biggest element is bubbled from unsorted sublist and moved to the sorted. That is what. So if you want to make increasing order, two options are there. Smallest one you keep in the first position, second small, like this, or largest one at the last, next largest will be at the last but one, like this. Of course, a list of n elements requires at most of n minus 1 passes to sort. Okay, yeah, here we'll see what is one example of bubble sort and a program, of course without separate function, with separate function and execution I'll do. And sorting only first half we have seen in selection sort also, so here also we'll see, and sorting only second half, and of course first half increasing, second half decreasing, all these things. And of course the very most important in it is complexity in bubble sort. Is it same every time? Best case, worst case and average case. So there is a special case in bubble sort. So what is that special case where you will get the complexity as big of 1? What is that case? Is it best case, worst case and or average case? Why? So when it happens, okay. So in general, of course, bubble sort also have big O of n square, but when you will get big O of n, so that special case also we'll see now. Yeah, I have taken the example initially the elements like this. So what you have to do first whenever you go for bubble sort, okay. Let us suppose this process I am doing here, like whichever is the largest I am keeping at the last position, next largest will be at the last but one. So in our example, if you see, of course the 85 is the largest, has to go to the last. Of course next largest is 56, should come at last but one, next will be 48, like this. Is that right? So anyway, we'll make it, okay. Its original list, the first thing, the first two elements, starting from first two elements, so 25 and 85. So now you check it out, are they in a increasing order? 25 is less than 85, yes, true, no need to swap. If not, then you have to swap, okay. So that is what, so you have taken this to 25 and 85, so order only, so increasing order only, so no need to swap. Now what you need to do, this part is over, you cannot consider 25 now you have to consider this position. So 85 and 48, you can see now 25 and 85 as it is. Now 85 and 45, I told you, no adjacent swapping, always it has to go for adjacent whenever there the condition is false. So now you can say, is that 85 is less than 48? No, right? So now swap it. So 48 will come here, 85 will go here. You can see it is not at all completed the passes. So where we have seen in selection sort, in each line one pass is completed, but till now we didn't finish one pass. Okay, I'll tell you, I'll explain clearly. You can see this one. Yeah, 85 and 48 swapped, so it will become 48 and 85. Now which position you have to take? 85, not 48. You can see first we have started from here, next this one, so all like adjacent 85 and 48. Now 85 is on. Now what you need to take? 85 and 8. Now you can see 85 and 8. Is it proper manner like increasing order? No. 85 is less than 8? No. So swap it. So 8 and 85. Now what you need to take? Position will change from here to here. That means 85 and 32 you have to take. So again not in proper order. So that's why swap it. Now 85 and 56, right? So again swap it. So this is what completed. Now one pass is completed. Now you can see. Now after one pass your largest element from the list is at the last position. So this is what one pass. Whereas in selection sort we just checked what is the minimum element, just swapping with the first element, and we kept it as one pass. Here 85, that is the largest element, it can be kept by using adjacent swapping here. Okay, so now what list of elements you need to take? Only that is unsorted sublist. Okay, so that means left part, that means the line to the right part will be always sorted, line to the left part will be unsorted. You can see now the next one. Anyway, 85 is sorted, that is over. Okay, now the next thing is I'll take 25, 48, 8, 32, 56. Okay, so now you can see from where you need to start. Again starting from the first 25 and 48. Are they in proper order? Yes, no need to swap. Next 48 and 8 adjacent. No, 8, 48 and 8. Yes, 48 is less than 8. No, so that's why swap. Now which position? 48 and 32. Yes, again 48 is less than 32. Again no, so swap it. Now 48 and 56. Is that 48 is less than 56? Yes, true. No need to swap. So now keep it as it is. Now the element which is the largest, 56, at the last but one position. Now 56 and 85 which are sorted sublist here. Sorted sublist will come from here. Okay, unsorted will be here. Yeah, next we need to take the elements only 4. See, every pass after pass 2, so 2 elements are over like this. So next pass, so like this you need to consider. Anyway, if I go with the next pass, 25 and 8, are they in proper order? No. So 25 is not less than 8, so 8 and 25 it will become. Now 25 is less than 32. Yes, true. Yes, no need to swap. 32 is less than 48. Yes, no need to swap. Okay, so that's why it will be 32. Here 48 will be as it is. Here 56. Here 85. Now 3 elements are over. 3 elements are sorted. Now you can check it out here. 8 and 25 proper order. Next, no need to swap. 25 and 32, no need to swap. Okay, now come to here 8 and 25. Yes, no need to swap. So like this. So this is pass 3, right? Next pass 4 and pass 5. Like this you will get it. Anyway, here also n-1 passes are required. So like this we have to complete for the bubble sort. So that is the main difference. You can see in selection sort you need to find the minimum among all the elements on the unsorted list. From that you have to swap with the first element, whereas in bubble sort every time you have to make adjacent swap so that you will get the largest element to the last position or smallest element at the first position. Anyway, either way you can consider, but you have to follow only one procedure, either largest or smallest, but not both at a time. So that is what about here bubble sort. So like this we have to complete for bubble sort. You can practice these things if you want. You can practice. Okay, bubble sort. Now we'll see the program for the bubble sort, what we have done here. So anyway, this is a program where without using a separate function, right? So simply I have taken here the elements, and is the size of an array is I have taken with the size 2000. Of course you can take, it is up to somewhat, it's not so less, not so high. Okay, so temp and I comma j, enter the size of an array, of course %ld ampersand n. So taking the size of an array, here the elements I am reading. Okay, this is taking the input. Now the logic resides here from line number 11 up till here 22. So now you can see here what we have done initially. I started from 0 and j also starts from 0. Why? Because if you clearly observe in our explanation, always I am starting from the first only initially. So I started from 25, pass is over, next again I am starting from 25. That means always I am starting, but I am not going till the last. Why? Because every time I am reducing the length, size. If there are 6 elements, now after pass 1 I am taking only 5 elements, after pass 2 I am taking only 4 elements. Am I right? So after pass 3 I am taking only 3, like this. So this is what the last part is reducing. So that's why you can see I started from 0, j started from 0. I has to go up till n-1, n-1 passes. How many passes are required? But j less than, it's not up to n-1. You can see n-i-1. Is that right? Yeah, you can say, let us suppose if I have at pass 4. So what happens? Pass 4 means, you can see I value will be 4. So like this you need to consider. You can check it out. First time if I take let us suppose 6 elements are there, 6 minus I value will be 0 anyway, minus 1. So 6 minus 1, 5. Okay, 0 to 4 only, right? Like this. So next 0 to 3 only you will get, next 0 to 2, 0 to 1. So and now what you are checking, if a of j is greater than, so when you have to make swap, adjacent swap, where there is a, this condition is true. So a of j is greater than a of j plus 1, right? So the next element, if that is lesser than the first element, so you have to swap it, right? Yeah, that is what. So this I am swapping by taking temporary variable, and you can observe from the coding, like whenever you find a of j, j plus 1 or a of I plus 1, that is the comparison. If you consider, that is always adjacent swapping. Okay, and if you get like a of I with a of j, it might not be adjacent. But if you get a of j with j plus 1 or a of j with j minus 1, that means always it is adjacent, right? So this is the adjacent swapping which has to be done when this condition is true, right? If not, we are not swapping. Okay, right? We have seen that example also. If 8 and 25, if I take 8 is less than 25, yes, true, no need to swap. Is that right? If I give 25 and 8, is that 25 is greater than 8? 25 is greater than 8, yes, true. So that's why you have to swap. So like this we need to make it. So this is what the symbol of bubble sort, first thing. So like this it will do, and finally I want to print the elements here. This is for separate function. Okay, without separate function. This is with separate function. You can see the same logic I have written, and minus of course I have taken here in braces. Same logic, everything is same I have written. So I'm showing the codes like this for your theoretical, might be for your exam point of view. So how you can write it. Okay. So when you want to write the functions, you have to get in the concept of functions very well. How you need to call the function, what are the parameters you have to give, what are actual parameters, what are formal parameters. So all those things, when you have to return, when you want to write void, all those things are very most important when you write the concept using functions. Yeah, we'll see this one with execution now. I'll execute this program, and I'll show you, and I will make it the things, and of course special case also I'll try to execute everything. We'll see now. So this is a program which I explained, and I copied to the code blocks. Simply the program initially I declared, I have taken the inputs bubble a comma n, which I am calling, and here you can see whatever the code I have written, I just copied. Of course here I have written a of I, right? It should be a of I. Okay, yeah, here there also you can change it. Yeah, anything, any mistake? Okay, let me execute first. Yeah, enter the number of elements. Let me take 7 elements, something like 56, 23, 76, 84, 65 and 43, and one more element is required, right? Yeah, I'll take something like 6. The output you can see, which is 6, 23, 43, 56, 65, 76, 84. Is that right? So anyway, you want to see, if you want to see this one in pass by pass, like every time how it is taking through adjacent swapping. So where I explained, no, right? 56, 23, so not in an order, so swap. So that also we'll see how to see simply in our code only. Make some changes so that you will get that. So simply writing this one inside, right? Yeah, so or else keep this brace inside here after completion of this. But one thing you need to remember, you have to change this variable I, right? Why? Because I variable, the value changing inside the loop, right? So that's why I'm taking an extra variable k, where this has to be a of k. And check it out, k variable is not declared. Yeah, now let me check it out once again. There's the number of elements. I'll take 7, something like 20, 56, 23, 86, 54, 45 and 7. One more element, I'll take 15. Yeah, we'll see. Now see, in the first pass you can see 56, 23 is swapping, 56, 86 no swap, 86, 54 swap, and you can see 86, 45 swap, 86, 7 swap, 86, 50. So 86 at the last position you can see. Now from the next, 56 is readily there, so no need to swap. And anyway 23, 54, 23, 56 no swap, 56, 54 yes swap. You can see here 56, 45 swap, 56, 7 swap, like this every time. 56 will come at the last, and next you can see 54 will come, next 45, next 23, next 15, next finally, that's it, the last element, no need to swap, right? So this is what happens. And anyway 7 elements, you can see 6 passes are required. So like this we need to complete the execution of bubble sort program. So like this. A small correction here, in previous I kept here a of k, so but it is actually a of I, right? So where I have started for I loop, okay, I have taken a variable I, so that's why here it is a of I. Of course if you go with k equals 0, then you can keep it as a of k like this, right? So I just kept it as a of k there, so you can make the correction it as a of I. If you keep inside and if I use k variable, then this is fine, a of k, but here it is a of I. Okay, yeah, so that is what. So we have completed this one, bubble sort example, okay, without separate function, with separate function. Of course execution is also finished. Now we have to go for sorting only first half of elements, how to do, and sorting only second half of elements. For example, okay, if you see this one, let us suppose if I take first half, means like this, only I want to sort 25, 85, 48. That means the output should be 25, 48, 85, and this should be as it is. And another question is only second half, this part has to be sorted. Anyway here in this example it is already sorted, but if not, it should be sorted. The first part should be as it is without sorting, whatever it is there, as this should be there. And the last question is one more question, arranging first half in increasing and the second half in decreasing order. So that is also we'll see. So first half of the elements in increasing, second half in decreasing. Okay, after that we'll see complexity. So I'll directly go with the execution part. What changes I need to do, I'll tell you. So this is a program I think we have seen. okay, where the function bubble is here and the logic is here, which sorts the each and every element. Now we have to only sort first half of elements. Anyway, that I explained this one in what is it, selection sort. Okay, now we'll see this one in bubble sort. What you need to do, how to consider only half of elements. See, if you do this part, I think you feel like, okay, I understood it very well. Okay, yeah. So I equals 0, it is going till the last. Can I keep it as I less than n by 2 minus 1, so that it goes last but 1? This is fine. And what about j here also? Is it exactly required? Again, if I keep n by 2 minus of I plus 1, so I am taking only half the elements, first half only I am touching. So like this I have just changed that. I think no need to change the remaining things, right? Okay, anyway, just I'll keep this one, the execution I'll keep outside. So every time I don't want to go for the part and I want to see the final one, only one execution part I want to see, I'll keeping outside. Okay, just let me execute. We'll see any sort of the errors. Okay, enter the number of elements. If I take something like 8 elements, so something like I'll take 45, 32, 8, 57, then 65, 34, 50, 87. The output you can see. So the first half of elements 45, 32, 8, 57, these are sorted. You can see 8, 32, 45, 57, 57. Now what about the second part, 65, 34, 55, 87? They are as it is. You can see they are unsorted. So this is what you need to check it out, how to make only first half of the elements to be sorted. What if I want to sort the second half? That means only second half, first half should be as it is. What changes I need to do? Anyway, first I'll make it as it is for the program, which is the bubble sort one for complete elements. So this is the program. I think we have seen for the complete elements. Now I have to make for only second half of the elements. What changes I need to do? So now actually it started with the first element, right? I equals 0, j equals 0, but we have to start only with the second half, right? So from the mid, I can say. So that's why instead of I equals 0, I'll keep it as n by 2. It's not n by 2 plus 1. You can check it out. Why? Because index starts from 0. Is that right? So n by 2 is correct. Okay. Is there anything to change? Yeah, yes. Why? Because here you can see I kept I equals 10 by 2, j equals 10 by 2, where j less than, if I keep n minus I, is this correct? I think no. Why? Because I means initially n by 2. N minus, if I generally take n by 2, means it goes half. That means definitely it is not going to this j loop, right? So that's why it should be, it is not I exactly. That means it should, anyway, it should go till the last, right? N minus 1 till it has to go till the last. That's why instead of this you have to keep I minus n by 2. Now you can see, let us suppose if you want to go for 8 elements are there, I starts from 8 by 2, 4. So here also 4. Here 8 minus, here I value is, what is I value? It is 4 minus 4, which is 0 plus 1. Anyway, 8 minus 1, 7, it goes to the last. Next position, it is 5th position. I value is 5. 5 minus 4, which is 1, 1 plus 1, 2. Yeah, 8 minus 2, 6. It is going. Yes, fine. Absolutely fine. Yeah. So the changes are required is I equals 10 by 2, j equals 10 by 2. And here also you have to make the change. Of course, here it is not required. Okay. Yeah. We will execute. So 8 elements I'll take. Something like 34, 25, 6 and 78. Then I'll take 45, 34, 98 and 7 I'll take. You can see here 34, 25, 6, 78. So 34, 25, 6, 78 as it is. the next 4 elements are sorted. You can see 45, 34, 98, 7 will become 7, 34, 45, 98. So this is what you have to check it out carefully. So this is about the execution of bubble sort, that is first half and second half of elements to be only sorted separately. So this is fine. Now the question is asked, the next question is first half of elements in increasing, second half of elements in decreasing order. Okay, yeah, before that I'll keep it the original bubble sort program first, where we have taken like this, and it is n minus I plus 1, right? So this is the original bubble sort program which will sort all the elements. Now we have to make first half of the elements in increasing order. Anyway, this is for increasing order, right? This program is what the change we have to do if I want only decreasing order, all the elements to be decreasing order. What change I need to do? Simply here you have to keep it as, instead of greater than, you have to keep it as less than. The answer is over. Is that right? Yeah, if you want you can check the output once. I will clarify your doubt if you have. If I take 6 elements, 34, 2, then 89, 67, 45, 43. Okay, so element should be in decreasing order, you can see. So only one change I have done is, instead of greater than I kept it as less than. That's it, right? So like this you have to do. So this is what, okay, instead of greater than I kept it less than. Okay, I'm again changing this one. Okay, greater than. Now this program for increasing order. Now if I want to make first half of elements in increasing order, okay, and second half in decreasing order. So very simple thing how to do is, first you copy this logic. Okay, first I'm copying this logic, I'm copying, and immediately you keep here after this completion of this one. Okay, yeah, I'll paste here. Okay, 2 nested for loops here. So here this one is same, I copied here whatever is there. Okay, exactly I copied. Now this part I'll take, that is line number 15 to line number 26. I will use it for increasing order. From 27 to 38 I'll use it for decreasing order. So for increasing order we have done what we have to do. Increasing order, I have to take I less than n by 2. Again j also, here j less than n by 2 of minus of I plus 1. That is fine. This is for increasing order, first half of elements. What about decreasing order? The first thing, decreasing order, instead of greater than you have to keep it as less than. This is fine. So which elements to be decreasing order? Second half. Second half we have done right now. What is the logic? I should be n by 2, j should start from n by 2, and j less than also we have done n minus of I minus of n by 2. That's it, right? So the changes are I equals 10 by 2, j equals 10 by 2, j less than n minus of I minus n by 2 plus 1. So if a of j, if you keep greater than here increasing, less than here decreasing order. So shall we see the output for this? Yeah, I'll take 8 elements. Okay, I'll take 30, 20, 50, 10. Okay, anyway I'll go for 80 here, and here I'll go for 40 and 18, 20, 5 I'll take. Okay, 90 I'll take. Okay, anyway 2 same numbers, of course not so problem, but we'll see the clear output here. Yeah, so first half of elements to be increasing order, next half should be in decreasing order. We'll see this output. You can see the first half in, so 30, 20, 50, 80 will become increasing, 20, 30, 50, 80, and next half 40, 85, 25, 90 decreasing. You can say 90, 85, 40, 25. So this is what I want to explain. So first half of elements in increasing, second half decreasing. How easily? Of course you may have other methods, but how easily you can write the code if you know the basic bubble sort program. So that is what I want to explain. Okay, we have completed this part, and this part also, right? Now the complexity, what is the complexity of bubble sort, and also we'll see what is a special case which is in bubble sort. Okay, we'll see this one. So the complexity part, if you consider, anyway you are taking two nested for loops, of course has to be executed compulsory most of the cases. Okay, in worst case I am talking about first. So worst case, that is, so you must have to execute both. Okay, nested for loops, it has to go till the last, that's why it is big of n square. So this is what. So what about best case? Is there any best case you are finding here? Yes, the answer is yes. That is only I want to explain. It is a special case. What is that special case? I'll explain now. So the specialty of the bubble sort is, if you give the elements, the input elements all in sorted order, the bubble sort will execute with big of n only. Big of n only. I'll tell you how it is true. So here, if you give all the elements in sorted order, there is a choice that, of course, we have to write the code. We have to write 2 more lines extra, so that it will execute in big of n only. So what is that case? We'll see. So how it can be done? So this case is true only for if the elements you give in sorted order. Let me take an example. Let us suppose if I take these elements, of course the bubble sort will go, of course at max it will go for big of n square. It has to execute for each and everything. Okay, so like swapping, adjacent swapping will be done. Now what about this one? If I give elements like this, 10, 15, 20, 25, 40, 43, 57, all are in sorted order, but you are asking bubble sort program to sort this one. How it will sort? We'll see. So first it will check 10 and 15. Are they in sorted? Yes. No need to swap. Okay. So 15 and 20, no need to swap. 20 and 25, no need to swap. 25, 40, no need to swap. 40, 43, no need to swap. 43, 57, no need to swap. So this is a one pass, right? After going through one pass, if you see, is there any swapping? This is what we need to check it out. If there is at least one swap, then we can go for the next part, right? Second pass. But if there is no swapping, immediately you can say that yes, no need to swap, all the elements are in sorted order, and no need to iterate the I loop. No need to iterate the I loop. That means your J loop will go for n times into I loop will go for only one time. That's why it is only big of n only. So in order to get that, what we need to do? So how to get that special case in bubble sort? So by observing this program, I'll tell you, you can check it out. I starts from 0. I told like one pass. What is that one pass? You can see for j starts from 0, j less than n minus of I plus 1. Here this condition, right? If this condition is true, then it will go for swapping, right? If this condition is never true in first pass, you can say, how to say, I'll just take a variable, simply another variable here, something like flag or f something. I'll give the value as 0, and if this condition is true at least once, in this I'll make f value as 1. Now after completion of one j loop, that means after completion of here, I will write some if condition, that if f is still 0, what I can say, if f is still 0, yes, all the elements are sorted, no need to sort. Is that right? If f value is 1, of course you can go like this. Is that right? So this is what a special case. And if f equals 0, no need to sort means no need to sort, immediately break there. Is that right? So this is what you have to do for this one, especially for bubble sort in best case. Anyway, we will see this execution also. These changes will make it and we'll execute this one. Yeah, this is a program for bubble sort which we have executed and we have seen, right? Yeah. Now what we'll do here is, as I explained, I'll take f is equals to 0, a variable I'll take, and inside the if condition I'll make it as 1. Now after completion of j loop, where j loop is completing here, so I'll take if f is still 0, So what I need to do, I'll write a separate one, and what I'll do here is I'll write printf, okay, no need to sort, or you can write it as all the elements are in sorted order, and immediately you can write break or exit, whatever it may be. Exit means the next statements will not be executed, right? So that is what. So I have written no need to sort if f is still 0. Yes, so I'll execute this one. We'll see any sort of the errors. No. Okay, I'll take something like 7 elements. I'll give like this 10, 20, 35, 40, 45, 50 and 70. So 3, 4, 7 elements totally. Yeah, so no need to sort. You can see the answer, and you can observe there j loop executes and I loop executes only once, right? I loop executes only once, one time. That is what big of n complexity. Hope you are understood this one. Okay, yeah. So this is a special case of bubble sort, the program, where you can see here. So I've taken f equals 0 and inside if condition f equals 1. So if at least once f is 1, then it goes in regular fashion, but f is still 0, so then no need to sort. That's it. So this is what about, especially about bubble sort program. So that I explained about best case, big of n. Of course in average case it might go to n square only. So this is about bubble sort program, and especially we have seen that special case also. So all those things we have completed. So now we'll go for insertion sort. We'll see what is this insertion sort, and of course the example programs and example. Then we'll go for complexities. Of course here also special case. In the name itself you can see insertion sort. So the list is divided into two sublists, of course sorted and unsorted. Here also you can see the sublist is picked up and transferred into the sorted sublist by inserting. Is that right? Inserting it at the appropriate place. Simply the insertion sort is like an element, what is the position of it in a list, so there it will be inserted directly. So many examples you can take in the pack of cards when you want to arrange according to the order. So a new card has come, you will check it out, what is the card and what is the position of that card. You can insert, right? If there is 6 and 9, if you get 8, it will be kept inside, I mean in between 6 and 9. So if you got a card 10, so you kept at right of 9, right? So like this. Okay, if I ask you like 10 people have there and they are like they are standing according to their height. The 11th person has come and we'll check it out, what is his position, so where he needs to be inserted, right? So that is what insertion sort. And anyway we'll see the example, we'll see, and without separate function and with separate function. Of course the two types we can see the code, okay, by using two for loops and if condition, and or if you can take by for loop and while loop. Okay, of course the complexity is same, but writing the code is different. Okay, we'll see that one, two programs, and then execution, then complexity. Of course here also a special case, that is how when it is big of n complexity. Okay, best case and how it is we'll see. Here also it's same like in bubble sort. Okay, yeah, we'll see those things also. So we'll see, this is the original list. Now you can see the bar. I told you, no, sorted and unsorted. Now the bar, this black bar is directly after the first element, right? So your insertion sort will start from the second element. That's what you can see how it will be. You can see, so now this 78 you have to take first. Okay, this 78 you need to compare with the previous, what is that? Okay, so like this 78, what is the position? Is it before 23 or after 23? Definitely after 23. Why? Because 78 is greater than 23, so that's why 78 will be after 23. So now 23 and 78 are sorted, remaining list is unsorted. Now you can take 45. What is the position of 45? Where it has to insert? Is it left of 23, right of 23? That means in between 23 and 78, or right of 78? Now you can see 45, is it less than 78? Yes, true. So that's why this has to be shifted. Not only this, it has to be checked. 45 is checked with 23. Is that right? Now 45, if we check with 23, it's not true, right? So that's why 45 only has to kept here. So it will become 23, 45, 78. So like this. Now 8, what is the position of 8? Is it after 78 or before 78 or before 45 or before 23? So first I'll check with 78 and 8. Okay, so 78 and satisfied, right? 8 is less than 78. Next check with 8 is less than 45, satisfied. 8 is less than 23, satisfied. Yes, so 8 has to be shifted here and all these elements are shifted to the right. You can see now what is the position, like this. Now 32 is checked with 78. Yes, true. Now 32 is less than 45. Yes, true. 32 is less than 23. No. So that's why position of 32 will be here only, right? So that's why you can see 8, 23, 32, 45, 78. And the last one 56. 56 is less than 78 is true. 56 is less than 45. No. So that's why position is here. So whenever the condition is false, then you stop there. Is that right? So this is what the insertion sort is. You can see here. Of course, here also 6 elements are there. Only 5 passes are required. If you have n elements, you require n minus 1 passes are required. So like this, we have to go for insertion sort example. Okay. Yeah, we can see the program now. So how to do this one? Anyway, I told you, like, if the index starts from 0, you have to start from 1 only. Why? Because for 0 there is no left element to compare. So for 1, so it goes to compare with 0. For 2, it will compare with 1, might be with 0. If not, okay, if here only not satisfied, it will stop here. Is that right? Like this. So now if you take this one, if you see the code here, right? So J starts from I. Okay, I starts from 1, J starts from that position only. If I is at 5th position, J also from 5th coming to the back, right? So that's why J value is decrementing. You can see. So J starts from I, and now you have to check it out. If it is less than, okay, so what this code is like, it is swapping every time. You can see it is like this. I'll go to the example. Let us suppose 8 is there. So 8 is checking with 45, right? So now what I'm here, yeah, 8 is checking with 78. Is it true? Yes, then swap. Okay, 8 will come here, 78 will go here. Now 8 is checking with 45. Okay, 8 will come here, 45 will go here. 8 is checking with 23. 8 is coming here. This is what the logic that is written here. Of course, another logic is also there. I will explain what is that logic means. I'll explain. I'll directly. So instead of swapping every time, I'll do like 8 is less than 78. Just take 78 here. 8 is less than 45. Take 45 here. Like this. Anyway, that also I'll explain afterwards. So first, this one is swapping every time. You can see until it is false. You can see if a of j is less than, then swap. Okay. So like this. Next also like this, every time it will do. If not, immediately break. No need to go to the next. Let us suppose if you take this one. Let us suppose if I take out something like where it is initially false, will take 78. Let us suppose 78. Let us suppose here 23, 45, 78 is there. Here let us suppose 98 is there. Is that 98 is less than 78? False. Directly goes to the else part. Directly goes to this else part, break. No need to do. Is that right? So this is what. So like this it will go. This is like swapping every time. Let us suppose if I take 32 78 swap. Okay. And 32 45 swap. 32 23. No. So that's why break. So this is what the logic here. Of course, without function here I have written. Here if you see, this is with function. I'm calling insertion function. Here you can see insertion function, the same code I have written. Else break. Like this we can write, and we can execute also this one. And not only this, instead of writing like this, we have another way also writing this program. You can see here, this is a program too. You can see. So I starts from 1, that is also fine. I less than or equals to n minus 1, which is also equals to I less than n. That is fine. I have taken a temp equals to a of I, j equals to I minus 1, this while loop. So what is the logic here? It is written as, I told you, no. So let me take an example. Yeah, here. So what we have done, 8, if I take 8 and 78, okay, less than, then I swapped in the first program. But here I'm not swapping, I'm simply keeping this 78 here. But where is 8? It is in temp. It is in temp as it is. So here 78, here 78. Now what is the next one? 45. Is that 8 is less than 45? Yes, true. So that's why this 45 will come here. Okay. Now next, 23 is 8 is less than 23? Yes, true. So this 23 will come here. Now this is over. Now here I'll take the temp at the end like this. This is also fine, right? Let me take another example. 32. 32 is less than 78? Yes, true. So that's why 78 is here. Anyway, 32 is in temp, right? 32 is in temp. So 78 here. Now 32 is with 45. Is it less than? Yes, true. So 45 will go here. So next, 32 is less than 23? No. So that's why stop here, and here you just keep 32. So this is like, instead of every time instead of swapping, it is like rotation. It is a concept of making rotation. It is like rotating the elements to the right. Is that right? So this is rotation concept, and this is swapping concept. This is insertion sort with swapping concept. Of course, this is also swapping. This is with rotation. So like this also you can do, both are correct. So anyway, I'll go for execution of these two programs. First I'll go for this one, whether it will execute properly or not. I copied everything. Okay, you can take somewhat big value of array. Yeah, I have taken the array elements and I'm calling insertion function. I have written the same thing here. You can see. So if it is less than, swap, otherwise break. Okay, directly I have written, and every pass I am printing. That's why I have written inside the I loop. This one you can see. That's why I have taken k loop, k variable. I am executing this one. I'll take something like 7 elements. Okay, 45, 32, 78, something like 8, 56, 97, and one more element, 42. So we'll see this one, the output every time. Yeah, after pass 1, that is 32 starts, 32, 45 over, remaining are as it is. Next 78, of course 78 is less than 45? No, as it is. Now the next one, 8 is less than 78? Yes. 8 is less than 45? 8 is less than 32? Yes. Next element, 56 is less than 78? Yes, that's why, and it's not less than 45. Stop here. Next 97, okay, here only. 42 is less than 97? Yes, true. Less than 78? Yes, true. 56? Yes, true. 45? Yes, true. So will be here. So this is what, of course there are 7 elements, that's why 6 passes I told you, no, n minus 1 passes are required. So like this, insertion sort with swapping every time. And anyway, we'll see the another code also. This is a one type of code. Yeah, I copied this one by using while loop. Here you can see. So how it is, temp a of I, the value you are keeping, and this is rotation until the condition is false. Okay, yeah, this is a rotation until the condition is false, or it reaches to the initial index. Okay, and finally what is a of j plus 1, keeping in the position, that is rotation part. So we'll see this one execution. I'll take the 7 elements, 45, 32, 78, 8, 56, then 96 and 40. Now we'll see this one. Yeah, 45, 32, so 32, 45, 78 here only as it is, here 8 directly keeping here. Next the same thing, you can see 56 here, and 96 same position, 40 it has to go here. So like this we can go for insertion sort. So like this in 2 ways you can write. One is with swapping like this, and the another one is with rotation. Okay, hope you understood this one. Now the last one is complexity. What is the complexity of insertion sort? You can see. So anyway, worst case it has to go to the n, of course n square times 2 nested for loops. Okay, in the worst case it has to go big of n square. Now for average also. Now what about best case? There is a best case exist here also, if the elements all are in sorted order. Okay, we'll take that case, how it is in all in sorted order. Let us suppose I'll take the elements here. Let us suppose I'll take the elements here 10, 20, 30, 40, 50, 60 like this. Now let us suppose if I start from 20 and 10, is the 20 is less than 10? No. Is that right? So directly break means this J loop will go one time only, right? So it won't go. Break means comes out of the J loop. I value 2 comes to 30. Is that 30 is less than 20? No. Again J loop one time. Next one time. Next one time only. One time. That's it over. So if you take 6 elements, only 6 times it is going. Is that right? So this is what, if you take n elements, only n times it is going when the elements all are given in sorting order. So how to check this one? Means I'll take a count variable. Count initial is 0, and whenever it reaches to else part, so I'll count it as C++. So finally I'll check it out. Okay, I'll check it out. So how many counts are there? So that count you can check it out. Okay, and if count is equals to the n value, then you can say that it is already in sorted order. So like this we can write anyway. So this is about insertion sort. So the complexity in best case is big of 1, and you can make these changes. I think you can get the output for this one also. Okay, yeah, this is about insertion sort. So now we'll go for the merge sort program. Okay, the concept of merge sort as well as the analysis, of course the program, and we'll see the execution part also. And of course merge sort is best one compared to the above 3. So how it is best? Okay, when it is best, that also we'll see.